NEMA connector.
NEMA connectors are AC power plugs used for mains electricity in North America and other countries that use the standards set by the U.S. National Electrical Manufacturers Association. NEMA 5-15 is the standard electricity outlet found in almost every household and building in the United States. Similar and interchangeable connectors are used in Canada and Mexico. NEMA wiring devices are made in current ratings from 15 to 60 amperes, and electrical potential ratings from 125 to 600 volts. Different combinations of contact blade widths, shapes, orientation, and dimensions give non-interchangeable connectors that are unique to a particular voltage, current capacity, and grounding system. NEMA 1 and NEMA 5 are used for commonplace domestic equipment. The others are for heavy-duty or special purposes. The dimensional standard for electrical connectors is ANSI NEMA WD6 and is available from the NEMA website.
NEMA nomenclature.
There are two basic classifications of NEMA device, straight blade and locking. The straight blade 5-15 and 5-20 are found nearly everywhere in countries using the NEMA standards, and are intended for supplying lighter-duty, general-purpose electrical devices. Twist-locking types are used for heavy industrial and commercial equipment, where increased protection against accidental disconnection is required. Numbers prefixed by L are curved blade, twist-locking connectors. Others are straight blade and non-locking. The metal conductive blades are sometimes informally called prongs, as in three-prong plug. The numeral preceding the hyphen in NEMA nomenclature indicates the configuration, that is, the number of poles, number of wires, voltage, and whether single or three-phase. A grounding type of device is described as 2-pole, 3-wire, or 4-pole, 5-wire, etc. A non-grounding device may be 2-pole, 2-wire, or 3-pole, 3-wire, etc. The numeral following the hyphen is the rating of the device in amperes. The number is followed by the letter R to indicate a receptacle, female connector, or the letter P to indicate a plug, male connector. As an example, the 5-15 is the common 125V 2-pole, 3-wire receptacle. The L5-15R, while sharing the same electrical rating, is a locking design that is not physically compatible with the straight blade 5-15 design. The 5-30 has the same 2-pole, 3-wire configuration and 125V rating, but is rated 30A. Although there are several non-grounding device types in the NEMA standards, only 3 of them are in widespread use today. These are the 2-pole 1-15, still in use in millions of buildings built before the 1960s, and the 3-pole 10-30 and 10-50. The small hole near the end of the power, non-ground, blades of some NEMA plugs is used for convenience in manufacturing. If present, it must be of specified diameter and position. Small specialized padlocks are available to fit these holes, allowing lockout of hazardous equipment, by physically preventing insertion of locked plugs into a power receptacle.
Blade identification.
The blades of a NEMA connector are identified with
non-locking connectors.
NEMA non-locking connectors all use blades of various flat and folded shapes, except for the round pins used on grounding connectors. The plugs can be detached from the receptacles by pulling back on the plug body. These connector families have been designed so that grounding connectors for 120V and 208/240V cannot be accidentally intermated. NEMA wall receptacles can be found installed in any orientation. Neither NEMA nor the U.S. National Electrical Code nor the Canadian Electrical Code specify a preferred orientation, and different orientations may be found in the same building. When the ground blade of a receptacle is on the bottom, the neutral blade is on the upper left and the hot blade is on the upper right. All descriptions below assume this orientation, that is, clockwise order is ground, neutral, hot for 120V versions.
NEMA 1.
This two-prong plug and socket design, with two flat parallel non-coplanar blades and slots, is used in most of North America and on the east coast of South America on lamps. Consumer electronics such as clocks, radios, and battery chargers, and other double-insulated small appliances that don't require grounding, earthing. All NEMA1 devices are two-wire non-grounding devices, hot neutral, rated for 125 V maximum. NEMA1-15P plugs have two parallel flat blades, 1/4 inch, 6.35 mm, wide, 0.06 inches, 1.524 mm, thick, 5/8-23/32 inch, 15.875 to 18.256 mm, long, and spaced 1/2 inch, 12.7 mm, apart. Ungrounded NEMA1-15 sockets have been prohibited in new construction in the United States and Canada since 1962, but remain in many older buildings, and this obsolete design is still available for repair use only. Since January 1, 1974, all new power outlets are required to have a ground connection, using grounded sockets, typically, NEMA 5-15 or NEMA 5-20, that accept both grounded and non-grounded plugs. Replacement of obsolete NEMA1 receptacles requires either an NEMA 5, for two conductors plus ground wire configurations, or an NEMA 5 GFCI for two-wire non-grounded configurations, when a ground conductor is not available. Ungrounded NEMA1 plugs are still popular with manufacturers for certain applications, because of their low cost and compact size. They are upward compatible with widely available grounded NEMA 5 receptacles. Standards permit ungrounded plugs where the appliance does not require grounding due to low risk of leakage current, such as on double-insulated devices. In older plug designs, both blades were the same width, so the plug could be inserted into the socket either way around. Many plugs manufactured since 1948 are polarized. The neutral blade is 5/16 in or 7.938 mm, wider than the line blade, so the plug can be inserted only one way. Polarized NEMA 1-15 plugs will not fit into unpolarized sockets, which possess only narrow slots. Polarized NEMA 1-15 plugs will fit NEMA 5-15 grounded sockets, which have a wider slot for the neutral blade. Some devices that do not distinguish between neutral and line, such as internally isolated electronic power supplies, are still produced with unpolarized narrow blades. Cheetah plug adapters allow a three-prong grounded NEMA 5-15 plug to be mated to a non-grounded NEMA 1-15 socket. The adapters include a spade lug to allow connecting to ground, often via the cover screw used to attach the socket faceplate. NEMA standards exist for 1-15P, 1-20P and 1-30P plugs, and the 1-15R receptacle. There are no 1-20R and 1-30R receptacles, because 1-20P and 1-30P can mate with a corresponding NEMA 5 receptacle.
NEMA 2 obsolete.
All NEMA 2 devices are two-wire non-grounding devices, hot, rated for 250 V maximum. Although standards exist for 2-15, 2-20 and 2-30, this series is obsolete, and only Hubbell still manufactures 2-20 devices, for repair purposes.
NEMA 5.
All NEMA 5 devices are three-wire grounding devices, hot neutral ground, rated for 125 V maximum, with a 5-15, 5-20 and 5-30 being grounded versions of the 1-15, 1-20 and 1-30, respectively. The addition is a 3/16 inch, 4.763 mm, diameter round or U-shaped ground pin, 1/8 in, 3.175 mm, longer than the power blades, so the device is grounded before the power is connected, and located below them by 1/4 in, 6.35 mm, edge to edge or 15/32 in, 11.91 mm, center to center. Compared to the 5-15P plug, The 5-20P plug has the neutral blade rotated 90° and shifted so its inner edge is approximately 1/2 in, 12.7 mm, from the hot blade. The 5-20R receptacle may have a T-shaped neutral hole, to accept both 5-15P and 5-20P plugs. The 5-30 and 5-50 are larger, with 1 inch between power pins. 5-30 also has a bent neutral blade. All of these are uncommon, as twist-locking plugs are generally used for high-current applications. Both current blades on 5-15P plugs are nearly always narrow since the ground pin enforces polarity. If the ground pin is removed to make it fit a 1-15R outlet or extension cord, the line neutral polarity is lost. 1-15P plugs are also compatible with 5-15P sockets. In this case, the socket retains polarity enforcement. Cheater plugs, adapters that make a 5-15P plug fit a 1-15R outlet, are readily available and retain line neutral polarity, but are illegal in some countries such as Canada. Proper grounding is dependent on the outlet being an ordinary duplex receptacle with a correctly grounded center screw, and the grounding tab of the adapter being connected to that screw. The 5-15R is by far the most common electrical outlet in North America in buildings built since the mid-20th century. It is usually installed in a twin duplex configuration, which may be on a common circuit, or alternatively wired with each receptacle on a separate circuit, sometimes switched. The usual orientation in residential buildings is with the ground pin on the bottom, while in commercial or institutional buildings this pin is on top, per National Electrical Installation Standards, NECA 130/2010. Sideways installation is also permitted. In this case, NECA 130/2010 specifies the neutral pin is on top. In 46 of the 50 United States and all of Canada, tamper-resistant sockets are required in new residential construction as of November 2013. These prevent contact by objects like keys or paper clips inserted into the socket. In stage lighting for film and theater, this connector is sometimes known as PBG, parallel blade with ground, Edison or Hubbell, the name of a common manufacturer. In the motion picture and TV production industries, an extension cord that uses this type of connector, usually with 12 Iuben florins or 10 Iuben florins wire, is called a stinger. Generally, lighting technicians use these extension cords to deliver power to lights rated at 2000 W or less.
NEMA 6.
All NEMA 6 devices are 3-wire grounding devices, hot ground, used for 208V and 240V circuits and rated for 250V maximum, with the 6-15, 6-20 and 6-30 being grounding versions of the 2-15, 2-20 and 2-30, respectively. The 6-15 resembles the 5-15, but with collinear horizontal pins, spaced 23/30 seconds in, 18.256 mm, center to center. The 20A plug has a blade rotated 90°, and the 6-20R receptacle may have a T-shaped hole, to accept both 6-15P and 6-20P plugs. 6-15R and 6-20R receptacles are usually manufactured on the same assembly line as industrial, or commercial-grade 5-15 and 5-20R receptacles, with all 4 receptacles sharing the same triple-wide T-contacts behind the varying faceplates. The faceplate bonded onto the receptacle determines the final configuration of the receptacle. The 30A plug and socket look similar to the 15A one but larger. The higher current versions are rare, with twist-locking plugs such as L6-30 or direct wiring more common. Generally 6 series non-locking plugs are used for such appliances as large room air conditioners, commercial kitchen equipment, and the occasional home arc welder. Single-phase 6-50 is commonly used on farms for the silo unloader, and is used with a 6-gauge flexible power cord up to 200 feet long, 61 meters. NEMA 6 devices, while specified as 250V, may be used for either 208V or 240V circuits, generally depending on whether the building has a three-phase or split-phase power supply, respectively. The NEMA 6-20A or 6-30A found in many hotel rooms is often supplied with 208V and without a neutral.
NEMA 7.
NEMA 7 devices are 3-pin, hot neutral ground, connectors rated at 277 volts. A 15-amp 7-to-15 plug has the crowsfoot current-carrying pins of the Type I plug, but with a U-shaped earth pin. The 7-to-20 version has an enlarged neutral pin. 7-to-30 is a larger diameter connector, with an L-shaped neutral, while the 7-to-50 has an enlarged neutral pin, compared with the hot.
NEMA 10.
NEMA 10 devices are a curious throwback to an earlier time. They are classified as 125/250V non-grounding, hot neutral, yet they are usually used in a manner that effectively grounds the appliance, though not in a manner consistent with most modern practice. As commonly used, 10-to-30 and 10-to-50 plugs have the frame of the appliance grounded through the neutral blade. This was a legal grounding method under the National Electrical Code for electric ranges and electric clothes dryers from the 1947 to the 1996 edition. Since North American dryers and ranges have certain parts, timers, lights, fans, etc. that run on 120V, this means that the wire used for grounding is also carrying current. Although this is contrary to modern grounding practice, such installations remain common in the United States and are relatively safe, because the larger conductors used are less likely to be broken than the smaller conductors used in ordinary appliance cords, and the current carried on the neutral conductor is small. NEMA 10-to-20 devices are very rare nowadays, but are occasionally found in homes that once had a large window air conditioner.
NEMA 14.
The NEMA 14 devices are 4-wire grounding devices, hot neutral ground, available in ratings from 15A to 60A. Of the straight-blade NEMA 14 devices, only the 14-to-30 and 14-to-50 are common. The 14-to-30 is used for electric clothes dryers and the 14-to-50 for electric cooking ranges. The voltage rating is 250V. They are essentially the replacements for the NEMA 10 connectors above with the addition of a separate grounding connection. All NEMA 14 devices offer two hots, a neutral and a ground, allowing for both 120V and 240V, or 120V and 208V if the supply system is three-phase rather than split-phase. The 14-to-30 has a rating of 30A and an L-shaped neutral blade. The 14-to-50 has a rating of 50A and a straight neutral blade sized so that it does not fit in the slot of a 14-to-30. NEMA 14-to-50 devices are frequently found in RV parks, since they are used for shore power connections of larger recreational vehicles. Also, it was formerly common to connect mobile homes to utility power via a 14-to-50 device. Newer applications include Tesla Motors' mobile connector for vehicle charging, which recommends the installation of a 14-to-50 receptacle for home use.
NEMA TT30.
NEMA TT30, TT stands for Travel Trailer, is a 30A, 125V recreational vehicle standard, hot neutral ground, also known as RV30. It is frequently, and sometimes disastrously, confused for an NEMA 10-to-30. The RV receptacle is common in nearly all RV parks in the United States and Canada, and all but the largest RVs manufactured since the 1970s use this plug. The hot and neutral blades are angled at 45° from vertical and 90 degrees to each other, similar to NEMA 10 devices. The plug is slightly smaller than an NEMA 10 but larger than ordinary 5-to-15 plugs. The ground pin, however, is round, like those on straight-blade NEMA grounding devices. Referring to the diagram, the orientation is the same as the NEMA 5 plug and socket, with the receptacle neutral on the lower right. The appearance of this plug makes many people assume it is for 240V, but this is a 120V device. Adapters exist with the TT30 plug on one side and a 5 to 15 or 5 to 20 socket on the other side. When the cord is detachable from the RV, an L5-30 is usually used on the RV end of the cord.
Twist locking connectors.
Twist locking connectors were first invented by Harvey Hubbell III in 1938, and twist lock remains a registered trademark of Hubbell Incorporated, although the term is used generically to refer to NEMA locking connectors manufactured by any company. Locking connectors use curved blades. Once pushed into the receptacle, the plug is twisted and its now rotated blades latch into the receptacle. To unlatch the plug, the rotation is reversed. The locking coupling makes for a more reliable connection in commercial and industrial settings, where vibration or incidental impact could disconnect a non-locking connector. Locking connectors come in a variety of standardized configurations that follow the same general naming scheme, except that the designations include an L for locking. Locking connectors are designed so that different voltages and current ratings cannot be accidentally intermated. Many specific types exist. Only a few are listed below. Other types include special-purpose connectors for boats, 400 Hz circuits such as used for aircraft, and direct current applications. One apparent disadvantage of twist lock connectors is that in the event that the cable is accidentally pulled too hard, rather than the plug falling out of the receptacle, the exposed conductors may come out of the plug, causing dangerous shorts or shock hazards if the circuit is live. This is resolved in most cases by the connector having an integral strain relief.
NEMA ML1.
NEMA ML1 connectors are a series of midget locking connectors with a maximum specified voltage of 125 V. Supply connections are intended for single-pole hot neutral ground circuits with a nominal voltage of 120 V RMS. No grounding conductor is provided.
NEMA ML2.
NEMA ML2 connectors are a series of midget locking connectors with a maximum specified voltage of 125 V. Supply connections are intended for single-pole hot neutral ground circuits with a nominal voltage of 120 V RMS. A separate grounding conductor is provided.
NEMA ML3.
NEMA ML3 connectors are a series of midget locking connectors with a maximum specified voltage of 250 V. Supply connections are intended for two-pole hot neutral circuits with a nominal voltage of 120/240 V RMS. No grounding conductor is provided.
NEMA L5.
NEMA L5 connectors are a series of locking connectors with a maximum specified voltage of 125 V. Supply connections are intended for single-pole hot neutral ground circuits with a nominal voltage of 120 V RMS.
NEMA L6.
NEMA L6 connectors are used with circuits with a maximum specified voltage of 250 V. Supply connections are intended for two-pole, three-wire hot ground circuits with a nominal supply voltage of 240 V or 208 V, depending on phase configuration. The L6 connector does not provide a neutral connection. L6-20 and L6-30 connectors are commonly found on in-rack power distribution units in countries where the main supply voltage is greater than 120 V. They are also found in the US for heavy-duty 240 V equipment such as welders, where the higher supply voltage allows a lower current draw. These connectors are thus found where industrial equipment or large power tools are commonplace.
NEMA L7.
NEMA L7 connectors are used with circuits with a maximum specified voltage of 277 VAC. Supply connections are intended for single-pole, three-wire hot neutral ground circuits with a nominal supply voltage of 265 V. Typically, these connectors are found in commercial or industrial lighting circuits, especially where metal halide lamps are common.
NEMA L8.
NEMA L8 connectors are used with circuits with a maximum specified voltage of 480 VAC. Supply connections are intended for two-pole, 3-wire hot ground circuits with a nominal supply voltage of 460 V.
NEMA-L9.
NEMA-L9 connectors are used with circuits with a maximum specified voltage of 600 VAC. Supply connections are intended for 2-pole, 3-wire hot ground circuits with a nominal supply voltage of 600 V.
NEMA-L14.
NEMA-L14 connectors are used with circuits with a maximum specified voltage of 125/250 V. Supply connections are intended for 2-pole, 4-wire hot neutral ground circuits with a nominal supply voltages of 240 V or 208 V hot to hot and 120 V hot to neutral. These connectors are common on household backup generators, and on racks of power amplifiers in large audio systems.
NEMA-L15.
NEMA-L15 connectors are used with circuits with a maximum specified voltage of 250 VAC. Supply connections are intended for 3-phase, 4-wire LLG circuits with a nominal supply voltage of 208 VLL, Y 3-phase, or 240 VLL, delta 3-phase.
NEMA-L16.
NEMA-L16 connectors are used with circuits with a maximum specified voltage of 480 VAC. Supply connections are intended for 3-phase, 4-wire LLG circuits with a nominal supply voltage of 460 V.
NEMA-L17.
NEMA-L17 connectors are used with circuits with a maximum specified voltage of 600 VAC. Supply connections are intended for 3-phase, 4-wire LLG circuits with a nominal supply voltage of 600 V.
NEMA-L18.
NEMA-L18 connectors are used with circuits with a maximum specified voltage of 120/208 VAC. Supply connections are intended for Y 3-phase, 4-wire LLN circuits with a nominal supply voltage of 208 VLL and 120 VLN.
NEMA-L21.
NEMA-L21 connectors are used with circuits with a maximum specified voltage of 120/208 VAC. Supply connections are intended for 3-phase, 5-wire LLNG circuits with a nominal supply voltage of 208 VLL and 120 VLN. These 3-phase connections include neutral and ground. The pin in the middle is ground, and the blade with a right angle on the tab is neutral.
NEMA-L22.
NEMA-L22 connectors are used with circuits with a maximum specified voltage of 277/480 VAC. Supply connections are intended for 3-phase, 5-wire LLNG circuits with a nominal supply voltage of 460 VLL and 265 VLN.
NEMA-L23.
NEMA-L23 connectors are used with circuits with a maximum specified voltage of 347/600 VAC. Supply connections are intended for 3-phase, 5-wire LLNG circuits with a nominal supply voltage of 600 VLL and 347 VLN.
Special safety features.
Over time, electrical codes in the US and Canada began to require special safety features in the basic NEMA 5-15 and 5-20R configurations to address specific electric shock hazard concerns. The safety features listed below are not mutually exclusive. Tamper-resistant GFCI receptacle outlets are sold.
Ground fault circuit interrupter GFCI receptacles.
These versions of the 5-15 or 5-20 receptacle are residual current devices and have test and reset buttons, and sometimes an indicator light. In the US and Canada, they are required in many potentially wet locations, including outside outlets, bathrooms, some places in kitchens, basements, and crawl spaces. They work by comparing the current going out on the hot conductor to the current returning on the neutral conductor, and disconnect the circuit if the difference exceeds 4 to 6 mA. They are cheaper than GFCI circuit breakers and can be wired to feed additional downstream outlets so that putting one GFCI receptacle in a circuit protects all the plugs, lights, and switches downstream from it. They are also recommended for power tool outlets and locations where children might insert conductive objects into the receptacles.
Tamper-resistant receptacles.
Starting with the 2008 National Electrical Code and the 2009 Canadian Electrical Code, listed tamper-resistant receptacles that address electric shock hazards to children must now be installed in almost all areas of new or renovated dwellings. According to statistics cited by the NFPA, the code change adds only $40 to the cost of building an average, 75 receptacle home in the U.S., yet prevents shock hazards to a child that sticks a single, metal object into the receptacle. The new receptacles are expected to reduce the number of electric shocks to children because inserting a normal, two-prong electrical plug applies pressure on both sides of the outlet to open an internal, spring-loaded shutter, but a foreign object fails to do so and therefore does not make contact with the live electrical contacts. However, the device can still be defeated by inserting two objects simultaneously. Despite its weaknesses, the tamper-resistant receptacle is superior to protective plastic outlet caps which must be individually installed on each receptacle, and are a choking hazard when removed, and to sliding covers that children easily learn to defeat.
Leak current detection and interruption LCDI plugs.
Because portable air conditioners have caused many electrical fires, those sold in the United States now must have leak current detection and interruption, LCDI, plugs. The cords have a fine wire mesh around the conductors and circuitry to detect any current leaking from the conductors to the mesh, which would happen if the cord were damaged or frayed. These could be NEMA 5 to 15, 5 to 20, 6 to 15, 6 to 20 or 6 to 30 plugs, depending on the air conditioner. The plug is equipped with test and reset buttons on the housing.
Color code.
The color of a device neither identifies its voltage class nor power system. Because the colors are not identified by national standards, the purpose of color coding a receptacle is set by the building owner. In this case, building owners may select brown, ivory, white, almond, gray, and black receptacles in the 5 to 15 configuration to blend with the decor of a room. However, although colors are not standardized by NEMA, some industries utilize colors for certain applications, following de facto standards. Blue receptacles may indicate built-in surge suppressors. A red receptacle may indicate a special service outlet such as one connected to an emergency standby power source. At least one manufacturer makes a yellow receptacle, which identifies it as corrosion resistant. An orange receptacle is an isolated ground, IG, receptacle. A receptacle with a green dot is a so-called hospital-grade device. Such devices are tested to survive harder use than wiring devices intended for residential or commercial purposes. A receptacle with an orange triangle is an isolated ground device, where the grounding pin of the receptacle is connected to ground independently of the frame of the receptacle and wiring outlet box. The receptacle itself may be any color, though older common convention in the United States specified an orange receptacle rather than an orange triangle on the receptacle.
Breakaway tabs.
Duplex receptacles have breakaway tabs to separate the top and bottom outlets, so that they can be wired onto separate circuits. This may allow for one switched outlet for a lamp, or for two circuits when heavy loads are anticipated. Two branch circuits may optionally share a common neutral terminating on duplex receptacles, a condition sometimes referred to as split wiring, split receptacle, or half split. Neglecting to break the tabs when replacing a split receptacle can disable a switched outlet, or cause a short circuit, or accidentally parallel two circuits, depending on how the receptacle had been wired.
Obsolete devices. Original Hubble plug and receptacle.
An early American electrical plug and socket was invented by Harvey Hubbell and patented in 1904. Hubbell's first design was a socket which screwed into a lamp holder, like the early lamp holder plugs, but with a separable plug with pins or blades. U.S. Patent 774250. The 1906 Hubbell catalog shows this plug with a flush mounting socket for use in wall or floor. Other manufacturers adopted the Hubbell pattern, and by 1915 they were widespread.
American 125V, 15 Aries/250 volts, 10A Australian style.
A patent for this obsolete plug-and socket was filed in 1915 under U.S. Patent 1,179,728. It predated the NEMA sockets and plugs, but is similar to NEMA 10-20. The plugs and sockets used in countries such as Argentina, Australia and China are based on this type.
NEMA 1-15 style 5 receptacle socket.
This is a 5-way socket from c. 1928, and is able to accept modern ungrounded polarized NEMA 1-15 plugs. The socket is obsolete, as the current NEMA standard only allows a maximum of 3 sockets in a single receptacle unit.
NEMA 1-15 light switch style socket.
This is a rare light switch style 1-15 outlet. It has one vertical socket, and it can accept modern ungrounded NEMA 1-15 plugs. It is obsolete as it has little insulation, thus is a minor fire hazard when used with high wattage devices.